Good afternoon. Today's class is going to focus a lot on the process of recording information. So, that way, you'll know why you named your son Junior instead of Indiana, because that was the dog's name.
Love Sean Connery. It hurts me that he died, but may that man rest in peace. Alright, so welcome back to Fundamentals of Engineering Design with your host, me. So today's class, we're going to focus on design reporting and standards. Okay, so the first thing that needs to be noted here, and one of the most important aspects of design reporting, is why report? Why do we document our information? Why do we retain this information? Why is this slightly down? My camera's so high it should be able to see. Whatever, I'll just zoom out. It's the top of the board. Why are we reporting? What is the need for reporting? Well, if you look at it, first of all, everything you say is an argument. Everything is an argument. Okay? Even stating everything is an argument is an argument. Why? Because it's arguable. You can say anything and absolutely everything is arguable. You can provide evidence for both sides. Now, some evidences are ridiculous, so not every argument is valid, but everything is arguable. Everything can be questioned and everything should be questioned. We live in an intelligent society. We shouldn't just take anything for granted. You should be able to question absolutely anything. And as an engineer, everything you do and say should be questioned. If people do not question you as an engineer, you begin to become very lazy. And then it's, oh, well, you know, it's whatever. Everything you do, absolutely everything you do is questionable and can be questioned and can be something that people look to try to understand whether or not you did it right. So everything is an argument. Because everything is an argument, you need evidence for everything. Okay, if you ever watch Big Bang Theory, Sheldon Cooper, when he was a child, would actually document his bathroom schedules. He would document we're talking about poop in class now. Would document all of these aspects of his bathroom routine, how it felt, and try to determine whether or not he was sick based on this data. He was gathering evidence to determine objectively whether or not something was occurring. And that's very similar to the design process. You write down just about everything. Okay? Why do you write down everything? Well, because it serves as arguments for your decisions. When you make a decision, you can look back and see, okay, I was doing research on these materials. I discovered from this website that this material has these properties. I got this quote from this place. I heard from this source that this material is valid. Now, different scientific sources will disagree with each other. Science is not one single entity whereby it says exactly one message. Everything is arguable. If science says exactly one thing and one thing only, no question, nothing, it's just this. This is the way it is. If science says it that way, then there's no reason for us to study science. Because then it's memorizing facts, it's not learning the process. There's no validity in learning the process. If all the facts have already been, it's one way, that's not it. There isn't one the way that we absolutely know is true. Okay, there are a number of different things that can be true. There are a number of things that we have evidence of, and we believe that evidence supports it. However, that evidence may support something completely different. And we may eventually come to a broader state of mind whereby a different theory exists that better explains reality. Okay? So, everything is arguable, everything should be arguable, and as such, you should have evidence of everything. You should report things. Okay? Just in a broad sense, if you want to justify any decision you make, being able to go back, go through your notes, being able to go back, look through any reporting, standardized reporting you've done, is an excellent way of being able to prove that you know what you're doing. Okay? For your next assignment, you're going to be required to do an annotated bibliography. For this assignment, I didn't require it to be annotated. I just required you to be able to do some amount of background research. That background research serves as evidence because when you go to make a decision, you can reference your background research. Now, again, I didn't require it to be annotated. The next assignment I will be because I'm going to increase what I require out of you. We're building into expectations, that kind of a thing. But you will be able to look at your annotated bibliography, say this reference here says X information. I will trust this reference and I will make decisions based on that evidence and the ethics that I receive from that source. Now, the ethical expectations I expect out of a person reporting random things on Reddit on the internet. Okay. So there is very much, you have to be able to prove everything you say. If you design a system, and let's say you just take a 4x4 post, extend a string between it, another 4x4 post, maybe you embed those 4x4 posts 36 inches in the ground, just hard pack, dig a hole, fill it back in with dirt, you extend a wire between them and then hang a light from the middle. You should be able to justify every one of those decisions. Why is the embedment depth 36 inches? Why is it that you chose to have that be 36 inches deep? Why did you pick a 4x4 post? Why did you choose the rope that you did? Why did you choose the light that you did? Do you know that this is going to be able to withstand hurricane? Do you know that it's going to be able to withstand the weather? Is it going to be able to withstand an ice storm? If this thing experiences ice along the top of it and gathers a significant amount of ice, is that going to cause these posts to rotate in soil? Is this depth much? Is it too much? All of those questions you should be able to justify. And this is a very simple system. It's 2 sticks and a rope with a light. But you should be able to justify everything about it. And the design process reporting is necessary to get to the point where you can justify your decisions. For the project that you're currently working on with the design of the playground, being able to justify those decisions means you know that those playground equipment pieces work. Maybe you do some surveying of the public. Maybe your reporting is just that you talked to a couple people. That's still evidence. And that's evidence that you can use. Well, we felt like having a sidewalk that goes here would be beneficial because we assume that people will want to go from this direction to another direction. Okay? That's evidence. It's not much, but it's still evidence that supports why did you do this? Why did you make it this way? Okay? So everything becomes an argument. And one of the pieces of that argument that kind of answers the expectations for you is that because everything is an argument, it's important to follow standards. Standards, not stand-ans. Stand-ans. Well, what is a standard? Well, I had all of you look up ADA requirements for playgrounds. Those are standards. It is, you will design this way, and you do not question it. I know, I'm violating my own principle here, but that's what a standard is. It must be constructed in this fashion, must use these materials, must have these principles, must abide by these things, must have these functional requirements in order to be considered up to standard. Okay? So standards are a set of requirements These could be constraints, functional requirements. This could even be measures of quality, minimum levels of measures of quality. You know, it has to be this fast, has to have this little CO2 production, has to have this much power, has to consume this little amount of power. It could be any one of these things, but it's a set of requirements specifically related to constraints, functional requirements, and measures of quality that a design must follow. If you design according to that standard, you have to design according to this very specific specifications that are given to you. Now, the ADA requirements, they are fairly vague intentionally because, as I told you in the first week, the more constraints you have, the fewer solutions you have. So yeah, simply saying I'm going to have an ADA accessible thing means, okay, well, we're probably not going to make this 40-foot tall structure that you can only get to with a climbing rope or a climbing net. It'll probably have to be something a little closer to the ground. So yeah, it eliminates those really awesome methods, and which are sweet, but dang ADA requirements anyways. But it does make the park more accessible to other people. But it does, again, it limits the amount of different options that you have. It limits the scope of the number of solutions you have to that problem. So more requirements makes it make fewer solutions available. If the ADA requirements were too strict, every park would look identical. Then it would be like every park has to have a slide that looks like this, has to have swings that are wheelchair accessible, has to have which there are some of those, by the way, has to have this certain feature, has to have a track, has to, can't use gravel, must use wear surface pads. If every ADA accessibility standard was that stringent, you would have exactly one solution. So they are a little bit vague because they expect people to be able to create different solutions. You don't have to have every park as identical. I'm going down to the ADA park again. Oh, which one? It's not that. They want you to be able to employ your creativity. And on your end, that means you have options. But there are additional constraints. There are additional functional requirements. And there are additional minimum levels of measures of quality that are often associated with following a standard. Okay? So who creates standards? Well, standards are usually created by an overall governing body. A bunch of people get together and they say, here, we really feel this should be baseline functional requirements for anything that wants to call itself organic. Because yes, there is a group that does that. We feel like there's a baseline set for anyone who wants to produce a bolt that is called AISI 1020 steel or anything that's grade 5 hex nut. They create standards by which now you can categorize things based on their performance. Okay? So it's governed by usually international bodies. Sometimes just these bodies regularly meet to determine standards. They review the standards, they look to see if they're sufficient, they adjourn, that's it. A lot of these regulating bodies, such as ASTM, AISI, which is the American Institute of Steel something, ASTM is the American Society of Technical Measurements or something, I believe. You have ASME that has a number of standards associated with it. That's the American Society of Mechanical Engineers. You have a bunch of different civil societies. You have a bunch of different electrical, mechanical, HVAC societies. You have wiring societies. You have plumbing societies. There are just thousands of these organizations that put together standards and they say, well, a manufacturer wants to follow this standard. Here's how you do it. That's it. And then people who go to use those materials can say, okay, I need a bolt, but I want this 3/8 inch bolt to be able to handle 45,000 pounds of tension load, I need it to be standardized such that I know I'm not just getting a bolt that it looks like it's metal, but it's actually made out of, you know, rock. And it has a tensile strength of like 3 pounds. You don't want that kind of a bolt. You want a bolt that actually does what you need it to do. And following standards gives it that option. It makes it easier to buy standardized components, because then it's, oh, I need a bolt that can handle 45,000 pounds. Well, I can go down to Ace Hardware and buy a bolt. Rather than, oh, I need to contact a manufacturer, I need to specify the amount of loading that I need to specify diameter, threading, all of these things, send it off to the manufacturer. Manufacturer sends back a bolt. And it costs you $450. Whereas you can get that exact same bolt at Ace Hardware for $1.50. That's the beauty of standardized components, though. They sell them in bulk, they manufacture them in bulk, and you figure out how to use them. If you need something better, you find something better. You find a distributor of something better. You know, instead of grade 5, you get grade 8. Has better strength properties, better hardness properties, made out of nickel chromium, made out of a different type of steel. You can get those, and they're standardized. They follow a very standard set of regulations as far as how they're made. Okay, and that's the goal of standards. A lot of the things you will design in your life will require either the use of standardized hardware, or may themselves be standardized. There are standards for how to develop roadways. A lot of those are set by local governments. Local government, like Crete, City of Crete, specifies that all paved structures that vehicles drive on have to be 7 inches deep. And it has to use a certain type of Portland cement. That is specified by the local government. The regulating body there is actually local government. And they make that decision. They will meet regularly, review that, and stamp it. Although it's one person who makes that decision, so it's a real easy stamp. But that's necessary. It has to happen. The standards are set by government bodies. Sometimes the standards work with governing bodies. Like you'll have, for example, the NCEES, which is the National Council of Examiners for Engineers and Surveyors. They're the ones who issue licensure for engineers. Now, NCEES worked with ABET, which ABET is an international accrediting body for engineering education, to basically say, we want to ensure that the engineering education experience that every engineer gets at least follows a baseline guidance of how good it is. So NCEES requires ABET accreditation for a program in order to receive licensure, which is why our program is pursuing licensure, is so that our individuals can get, is pursuing ABET accreditation so that our students can get licensure. That's important to us. But then NCEES is now, while it itself is an independent organization that exists across all 50 states, NCEES is recognized by the state of Nebraska as the licensure body, meaning that you have to, in order to call yourself an engineer, a licensed engineer in Nebraska, you can't just walk around and be like, hey, I'm a licensed engineer. Like, where's your license? Don't worry about it. You can get arrested for that. Why? Because it's built into our laws that in order to be licensed, you have to be licensed through NCEES. So government does work a lot with private industry or nonprofit organizations to create these standards, to create these requirements, all these legal definitions, to make sure that everything is more efficient, more effective, more standardized. So you can't just say, oh yeah, that's a 45,000 pound bolt. How sure are you of it? No, I'm not sure at all. You can't say that. You can say, okay, look at my testing standards. Here, we did testing on similar, we did testing on bolts from the same batch of bolts that we did. We discovered here's the stress strain curves for them. It experiences this peak amount of stress. They actually have that reporting built into these standards to be able to prove evidentiary that it follows the standards. So yes, at the end of the day, Standards are present in everything, but they do require a significant amount of reporting. Okay, so how do you report? What does reporting really look like? Okay, if you have to report in order well, if you're using standardized hardware, you should be able to access a standardized report. That is one of the nice things about that. Standardized reports give minimum stress strain requirements, and if you buy a bolt that doesn't have the minimum stress strain requirements from a company, you can actually sue that company for producing errant hardware. That's one of the nice things about standards, is it removes the liability from you, the designer, and puts it on the manufacturer. So it's kind of a double-edged sword there for them, but it's whatever. How do you report? Okay, first of all, any materials that you get externally, where you are relying on someone else for information, that material you store in an accessible location. Oh. 20 years ago, that accessible location had to be a physical file drawer. You had to print it out. We were still, the .com world was still young. And yes, you had some file storage that was present on computers and servers, all of these things. But really you had to print these files out, locate them somewhere so that you could pull them out, scan them, fax them to somebody. Even 20 years ago, that was standard. Today's world, you are able to scan these documents and securely upload them to external hard drives, servers, clouds, where this information is accessible from multiple locations. That is acceptable in today's world. Some places will still require you to print them out, but those places are dwindling in number. Online storage has been proven to be viable for the long term, and people have come to accept that. Okay? So if you get testing certifications on a bolt that you received, you document that. You file that. You create a folder called testing certifications. You put it in there. You label it with the date you received it. You label it with all of this access information so that when you go back to find it, you can file it located in your Google Drive folder or in whatever your testing certifications folder is that you have. Okay? But it has to be accessible. That is key. The reason why I had you gather information prior to this, put it into a single document, is because it is important that's part of your reporting process. If I ask you a question, why did you do that? You should be able to look at your other examples and say, well, they did it. And here's the reporting that they had. And we trusted their work and we followed their work. Saves you steps, saves you time. But all you have to do is just store their information, where to find it. That way you can answer that question, okay? Reporting is key to answering questions. Okay, so store your external documents. Second step, if you do testing, you need to not only record the raw data that comes out of your test, you need to record the environmental conditions. You need to record the date. You need to record the reasons of why you're doing the test. You need to record the reasons of what you were hoping to see out of the test. You need to record everything about it. Why? Because if you just have a pile of raw data, hey, I'm going to hand you this raw data file. You tell me what it means. Sometimes the data columns aren't even labeled. But if you know the context of what you were hoping to see, what instruments were used, you do your standard reporting on what all was done in order to perform this test. If you do all of that, then you can look back and say, well, somebody had a question about whether or not our metals were strong enough. Well, we did this tensile test on them where we plugged it in, put in a load cell. This load cell was this, and you can get information on that load cell by going to the distributor's website because they provided all that information. And I'll show you the gains. It'll show you this. Here's the computer program we use to calculate that, to gather that information. It is located right next to the rest of the information in there. It's a lot of work to report that information. But if you want to consider yourself a good engineer, you have to do extensive reporting. It's a lot of gathering information because you were trying to prove an argument. This bolt has 45,000 pounds tensile force. And you will put hours of work into figuring out that one number. But you will be able to definitively prove it without argument, and that is critical because it absolves you of any litigation. Now, that's information that holds up in court. Nobody can sue you if you did the testing and you got the reporting. And we live in a litigation-heavy society. Okay, so if you do testing, record everything. What is everything? We're talking raw data. That's obvious. Environmental conditions. Dates, times, motivations. Why are you doing the test? And data collection methods. Usually including the hardware. Okay, so just doing a test, a lot of information you have to gather. And that's doing one test where you may be looking for one number, but you gather all this information because it verifies a point that you can specifically prove to somebody that this happened, okay? And sometimes this information comes in handy later on when somebody else wants to do a similar style of test, okay? So let's say other than just testing, let's say you do a design work. If you design something, again, record everything. Usually you'll have a design notebook, and in that design notebook you'll have sketches of your idea with dimensions. You may have physical properties. You may have short descriptions of your ideas. You may have different labeled components, names, definitions. If you call a piece a strut, you need to define what that means. Label it. Okay, when I have my pieces like this piece is the strut. Okay, you call it that. I mean, strut is a pretty standard term, but if you're trying to design something novel, maybe you consider it to be a strut, and then you just label it. Call it strut. Okay, but everything needs to be defined. But one of the huge pieces of this is you also need drawings. And these drawings have to be professional. Dimensions, materials, quantities, locations. It has to include a number of different items on here. And this is just for design. You need to talk about material specs. Oftentimes you don't do your own material testing. You get the materials from somebody else. And then you have to include those certifications, it's a testing process that has all of this information present in a very brief document that you can just hand to somebody and say, here, this was certified by X corporation. This is the testing. So you have to record everything. You write down your thoughts. Having a design notebook is needed. Okay, and at the end of the day, if you record everything well, you can look back on it and remember what happened. You can look back on it and have a really good firm foundation for what you did. Not everything ends up in your final report. Some information exists only in these intermittent reports, in this design report, in this testing report. Sometimes that's all it is. Okay. So one more thing that we're going to talk about at the end of this is you have an abstract due for your group at the end of this week. Okay? An abstract is an important piece of your reporting because it specifically details out what was done for your project, okay? And a good abstract for any engineering project contains the following elements. Your motivation for the work. Why did you do the work that you did? Why? Why is your work valid? Why is it important? Why is it relevant? Okay? Motivation. And then the second piece is, what did you do? Talk about why you did what you did. Then you talk about why what you did was important. What did you actually do? Okay? Well, if you're writing a report on, say, a playground park, a motivation would be there's a park space that the city is hoping to develop into a useful park for families and children. Okay? So that's the motivation. The work that you did then, as a part of this work, a design team put together a proposal detailing the pavement structures, the large-scale structures, grass spaces, foliage, pavement, etc., and needed to construct this. Standardized plans were developed in order to be handed off to a contractor for construction. That's all work that's done. Okay, and then the last piece is analysis. So you start out with, we built a park to make people happy. Second part, we put together standardized plans. We did all the research, we put together materials. This is intended to be materials that are handed off to a contractor to construct this park or playground. We determined that the overall cost of our playground is going to be X. We discovered that the playground would have an anticipated impact value of happiness of 3,000% on the community. When given a survey, the features according to this study were found to be very, very positively received by the community. Okay? Your analysis portion talks about how good was the work that you did. So you break this up into why you did what you did, how you did, what you did, and then how well you did it. Okay? And you be honest about the analysis too. Sometimes the analysis says more work is needed. In fact, that's what's in a lot of abstracts. But a good abstract contains three elements. I will be looking for these 3 elements in your abstract. And yeah, I know your project isn't done yet, but you're supposed to write your abstract as if it is done. Okay, because your abstract will oftentimes be submitted. That's going to be what's submitted. It's a short, usually 50 to 100 word paragraph describing what you did. The end. Some abstracts can be up to 250 words. Some abstracts need to be less than 50 words. I've seen that too. But most of the time it's 50 to 100 words. And if you can keep yourself succinct, cover these 3 topics well, and fit your abstract into that space, more power to you. Okay, the next video I'm going to get back into AutoCAD stuff. So I'm just going to sit down at my desk, turn my camera that direction, and then get started recording right away. So I will see you when you look at the next video. Actually, I'll be looking through your screen, because into your hearts, because that's what I do.